What if I told you that there were 800 million gray whales in the ocean, but until recently we didn't know what they did, and we didn't even know they were there? 800 million gray whales. Well, you'd probably think we in the marine biology world hadn't been doing our homework. Or maybe we got out a little bit ahead of California's Proposition 19. Or maybe that I was running for the Senate in Delaware. But in a very real sense, it's true. There's a mass of organisms that weigh the same as 800 million gray whales that we never knew about when you and I went to school. And those are the tiny little microbes that live in the ocean. Not the great iconic sharks and whales and bluefin tunas, but the bacteria and the viruses that we now know make up 90% of the life in the ocean. In this soda bottle's worth of water, we in science call it a liter just to keep amateurs out of the field. That seawater is teeming with life. In fact, my script scientists tell me don't think of this as a liquid. Think of this as jello, crammed full of bacteria and viruses with just a few little water molecules keeping them together. I'm going to tell you today 3 things about the life in seawater. And we've discovered this mostly just in the last decade. First of all, love your microbes. Love that ocean. What do these microbes do for you? Well, 50% of the oxygen that we breathe comes from life in the ocean, just like this. Those molecules are there, day in, day out, 7 days a week, 365 days a year, making the oxygen that we breathe. So breathe in, breathe out. Thank you, ocean. Thank you, 50% of the oxygen. What else do the microbes do? Well, for the last 150 years, they've been working overtime because they absorb a great deal of the carbon dioxide that you and our ancestors have been emitting since the Industrial Revolution. And boy, have they been working overtime for us. If it were not for these microbes, the ones that absorb CO2 and in 10,000 years will mineralize it and have it sink to the bottom of the ocean, if it were not for those microbes, our global warming would be even worse than it is today. Most of us think that about 1/3 of the CO2 that we've emitted so far has been absorbed into the ocean and processed in some way by these microbes. So 39% of, there's been a 39% increase in the carbon dioxide in the atmosphere. Think of it as blankets. We used to have 3 blankets on our bed. Since the Industrial Revolution, we've added a 4th blanket. For every 3 molecules of carbon dioxide that nature put there, we've added a 4th. Well, the ocean's CO2 has only increased 30%. That's because there's a little thin boundary between the atmosphere and the ocean, and it takes a while for all that CO2 to diffuse into the ocean. So it's marine microbes that are doing that job for us. Of course, marine viruses have a bad side. Yes, it's true. Like viruses here on terrestrial Earth, they infect organisms. They infect some seals, they infect fish. Very rarely do they affect humans. But they do infect mostly other microbes. Indeed, there's a cycle of molecules between what you and I regard as living, these microbes, these bacteria, these viruses, and what you and I think of as dead, inorganic chemistry, if you remember your high school chemistry. But every day, 30% of that life in the ocean dies and is reborn the next day. So the cycle of life and death is something that we humans have perhaps trouble understanding. Why else should you care about these viruses? Well, let's face it, they're going to save us. Malaria, Alzheimer's, immunity that we develop to antibiotics that we've invented in the last 50 years since penicillin. Where are these drugs going to come from? Well, many of you know that we're not smart enough to invent drugs ourselves on a piece of paper, out of thin air, out of our minds. Up till now, we've been using terrestrial templates, ideas we've taken from traditional medicines, molecules we've discovered in plants and soils around the world, in order to test them and see if they can be helpful for our drugs in the future. But it turns out we're using up all those ideas. And where are the next ideas going to come from? Well, they're going to come from laboratory analysis of molecules in the sea. Molecules in the wet sea, and particularly molecules in that bottom layer of sediments in the bottom of the sea. I'm told a sugar cube-sized piece of ocean sediment contains 1 billion microbial cells. And up in La Jolla at Scripps Oceanography, my colleagues are developing ways to sort through all of those billions, to find the ones that can help us, the ones that might save us and future generations from the diseases that exist today and the diseases that will inevitably develop in that rich tapestry of life we know as Darwinian evolution. So I predict the next generation is going to look back on the oceans, and as one of my colleagues say, is going to think about it as a bountiful source of salvation for the human race. But wait, there's more. What else can the ocean do for us? Well, I'm sure you've heard about energy security. The fact that our society has grown up using fossil fuels, almost in a way as if someone had constructed us to be trapped on this never-ending flywheel of fossil energy. I mean, how better could you constrain our society than to get us addicted to a drug that we can't find in our own country, has to come from the other side of the world in ships that are easily accessible to those who would like to do us wrong? Where are we going to get replacements for those fossil fuels? Well, part of the answer is going to be electricity and electrical cars. But part of the answer you see on the screen behind me is going to be algae biofuels. Now, at Scripps, we've been studying for 107 years, and I have to tell you, for 105 years, nobody cared. But the last 2 years, things are getting very, very exciting. What are little algae? They're little machines put here by nature to take sunlight and carbon dioxide and turn it into protein and fat. The protein story is another talk. You'll have to bring me back another time. But the fat story is what we're talking about today, because what that fat is and what it can be made is biodiesel. So think about these little engines. We can grow them in salt water. We don't need fresh water. We can grow them on land, desert land, that's not valuable cropland. And we can grow them right here in Southern California, in northern Baja, and be self-sufficient in fuel. Yes, it may cost more than our current fuel, but think about all the hidden costs of that gallon of gas that you buy in the pump. It probably comes from a long way across the other side of the world. We have to have a State Department to make nice with all the people that don't like us very much. We have to have a Department of Defense to ensure a supply when the State Department doesn't do its job. If we're growing our algae biofuel right here in Imperial County, Southern California, we don't have any of those costs. What we have is some self-sufficiency, and we know we can grow as much as we need. Is it here today? No. But I see a time, a decade from now, when we're going to be self-sufficient because of our ingenuity and because of our knowledge of algae. And you know what the best thing is about algae? They're carbon neutral. The carbon that they eat today and combine with sunlight to make your fuel is the very same carbon that they emit when you burn it in your gas tank, or more probably in the truck or the bus that's taking your goods to the grocery store or taking you to work. So they're inherently carbon neutral. So let's add it all up. Ocean microbes, making oxygen, burying carbon, drugs from the sea, algae biofuel, carbon neutral. You can't ask for a better deal than that. So I invite you to join the next wave with me. Think about what you can do with the ocean. Invest in a company. Start your own idea. Write a poem. Make a YouTube video. Yes, endow a chair, a professorship in algae biofuel. But above all, love your oceans and enjoy. Thank you very much.